Hi, I'm here to demonstrate how easy it is to use Moxa's industrial cybersecurity solution to protect your OT network. Moxa's industrial cybersecurity solutions includes EtherCatch and Industrial IPS, EtherFire and Industrial IPS Firewall, and Security Dashboard Console, which is a centralized management software. EtherCatch provides micro-segmentation that protects your assets at the cell level, and EtherFire establishes network segmentation and protects the network at the zone level. Finally, the SDC centrally manages the other two and offers the user a holistic point of view. What's special about this solution is that it is tailor-made for harsh OT environments. By combining cybersecurity technologies and experience from OT networking, Moxa's industrial cybersecurity solution was developed with these key features: IPS-IDS dual mode, fine-grained policy enforcement, virtual patch, DDoS protection, compact and rugged design. In this video, I will demonstrate virtual patch, fine-grained policy enforcement, and also how an IPS can block malicious traffic in your network. This is the layout of the testbed. On the left, we have the SDC. In the middle, we have EtherFire protecting the SCADA system, and EtherCatch protecting the PLC that is controlling the production line. Our first scenario is virtual patch. Patching is critical, but it might not always be performed on time, especially in OT environments. If a device is not properly patched, it is vulnerable to many known attacks. Let's see how easy it is to corrupt a device that is not properly patched. We've just exploited a known vulnerability of Windows that was used in the WannaCry attack. As you can see, the Windows-based SCADA instantly crashed. By deploying an IPS that can perform updates periodically to mitigate cyber threats, we can prevent such vulnerabilities from being exploited by attackers. In other words, we may delay patching of vulnerable systems by applying a virtual patch to the IPS. Now let's turn on our IPS and see what happens. In the previous attack, it was in monitor mode, which is IDS. Now let's switch it to prevention mode, which is IPS. Click Save, and the device is all set. Now let's try to target our SCADA again using the same exploit. As you can see, this time, nothing happens because EtherFire already blocked that vulnerability from being exploited. You can see all of this in the cybersecurity logs on SDC. As you can see, EtherFire successfully blocked that attack. The action it took was denied. Now the SCADA is secured and remains unaffected. Our next scenario is fine-grained policy enforcement using DPI technology. Nowadays, most OT protocols are not encrypted or authenticated. This means attackers can easily send a packet using the same protocol to tell your device what to do. Next, I will demonstrate how an attacker can easily take control of your device. A packet with SLMP write commands was sent to the PLC from the attacker. The PLC accepted the packet and executed the stop command. Imagine the damage this could cause in a real-life scenario. To prevent these types of attacks or accidental misconfiguration, you can create a policy that only allows certain protocols and commands. For instance, it is quite easy to set a policy that only allows SLMP read packets from a certain IP address to go through, and this will prevent the attacker from gaining access to your device. Now let's set our fine-grained policy for SLMP packets and click OK. We will go to Policy Enforcement, enable it, set it in prevention mode, and click Save. Now that everything is set, we'll go to the attack tool again and try to interfere with the conveyor belt. We click Stop several times, but as you can see, nothing happens because it is protected. We will go back to the logs of SDC and check the policy enforcement logs. As you can see, the asset is now secure and is out of reach to attackers. Our last scenario demonstrates our capability to block malicious traffic. Now, instead of using the real malware which could cause actual damage, we will use the ICAR test file. The file is used to test the response of antivirus programs, and it was developed by the European Institute for Computer Antivirus Research along with Computer Antivirus Research Organization. In this scenario, we will first set our device to IDS mode, then we will switch it to IPS mode. Now, let's send the ICAR file to the SCADA computer and see what happens. We click on the ICAR test twice. and then we go to the SDC's log file, you can see that the SDC's log file has logged all the attacks. If we scroll to the right, we can see that it detected it, but it didn't block it because it is in IDS mode. Now let's try to switch it to IPS mode and try again. We can switch it in the SDC console, click on Prevent, and click Save. Next, we will click on the attack again, so iCar test, click, click, and then we go back to the logs. You can see in SDC's log file that the attacks were detected. If we scroll to the right, we can see that it not only detects it, but it has also blocked the unwanted traffic. This could be very effective in preventing the lateral spread of malware inside your OT network. Now, what happens when there's a false alarm? Easy. Users can choose from over 5,000 rules and decide which rules to enable and which ones to disable in order to prevent this from occurring. This gives users more flexibility and protection. During this brief demonstration, I've shown you some key features of Moxa's industrial cybersecurity solution. If you wish to know more about how we can protect your network, please visit www.moxa.com/security or contact our local representatives. Thank you for watching, and see you next time.